All right, let's jump straight into this explainer and demystify the complex, but honestly, incredibly fascinating world of livestock feed formulation. If you're managing livestock, poultry, or aquaculture, you already know the deal. The feed you put in front of your animals, it completely dictates their growth, their overall health, and yeah, ultimately, your bottom line. But how exactly do we hit that absolute sweet spot, that perfect mathematical balance between peak nutrition and, well, economic reality? That's exactly what we're going to break down for you today.
Now, to really get why this matters so much, just look at this staggering metric. Feed accounts for a massive 65 to 75% of your total live production costs for most types of poultry and livestock worldwide. I mean, think about that for a second. That leaves just 25 to 35% to cover literally everything else. We're talking housing, labor, machinery, vet care, the whole shebang. So, a simple mistake in your feed formula, that's not just a minor oops moment. It can be financially devastating. There's basically zero margin for error here, which is why nailing this formulation is absolutely non-negotiable.
So here's our roadmap for today. We're going to cover the true cost of animal feed, check out a few formulation methods, dive deep into the famous Pearson square, look at balancing crude protein, and finally, wrap up with the exact steps for creating the perfect feed.
Okay, kicking things off with Section 1, the cost of animal feed. So what are we actually doing here? Well, the source material defines feed formulation as the process of quantifying the exact amounts of feed ingredients that you need to combine to form a single, uniform mixture, and this mixture has to supply all of an animal's nutrient requirements. Think of it kind of like a super strict budgetary meal prep. Every single ingredient you toss into that mixer has to completely justify its spot, based on both its nutritional payload and its cost. We're not just randomly tossing corn and soy together and hoping for the best. It's about absolute, quantifiable precision to create a diet your animals can actually thrive on.
And, this perfectly illustrates the duality of the job. It's this wild mix of hard science and subtle art. On the science side, sure, you're strictly matching chemical compositions and nutrient requirements. But the art side? That's where it gets tricky, because you have to account for physical realities. How is this feed actually going to flow through the mill? Does it make a high-quality pellet, or is it just going to crumble into dust? And most importantly, how does the animal's gut actually respond to it? I mean, you could have the most mathematically perfect formula on paper, but if the chicken absolutely refuses to eat it, well, it's completely useless, right?
Moving right along to Section 2, feed formulation methods.
Now that we know the stakes, let's look at how farmers and nutritionists actually solve this puzzle out in the real world. There are basically 6 conventional methods here. On one end, small operations might just rely on basic trial and error, manually tweaking numbers until the math kind of works out. In the middle, you've got algebraic, calculator-based approaches, like the simultaneous equation, the IMMI method, or the 2x2 matrix. And then at the absolute peak of industrial efficiency, huge commercial feed mills use complex, least-cost computer algorithms called linear programming. That's how they find the absolute cheapest combination of ingredients that still hits every single nutritional target.
Which brings us to Section 3, the Pearson square method.
This right here is a totally practical method for finding that sweet spot between pinpoint accuracy and everyday usability. And the best part is, you don't even need a supercomputer to do it. Let's set up the math. Say we're formulating a diet for carp, okay? And our target is 27% crude protein. What you do is place your available ingredients on the left side of the square. So, for example, we've got rice bran, which naturally packs about 8.2% crude protein, and soybean meal, which is a total powerhouse at 44%. Then you just drop your target protein goal, that 27%, smack in the middle. It's just a beautifully simple visual setup for what could otherwise be a really frustrating algebra headache.
All right, Section 4, balancing crude protein. Now for the fun part, actually solving it. And we always prioritize protein because, honestly, it's almost always the most expensive part of any diet, and we balance it perfectly first. So how do we do it? By simply subtracting the numbers straight across the diagonal and just ignoring any negative signs. It's that easy. Take the 44% from the soybean meal at the bottom left, subtract the 27% target in the middle, and boom, you get 17 at the top right. Then take the 8.2% rice bran at the top left, subtract the 27% target, again, ignore the negative sign, and you get 18.8 at the bottom right. Just like that, the math tells us we need exactly 17 parts of rice bran mixed with 18.8 parts of soybean meal to hit a flawless 27% crude protein mix. Fast, elegant, and incredibly effective.
But hold on, what if you have more than 2 ingredients? Well, for more complex formulas, you can actually group multiple ingredients together into basal feeds and protein supplements and use this exact same square. For instance, you can average rice bran and corn together to get a basal feed of 9.2% protein. Then group your soybean meal and shrimp meal together, which averages out to 48.35%. Plug those two new averages right back into the left side of your Pearson square, and suddenly you're formulating a precise 4-ingredient feed just as easily.
Once you finish this mathematical formulation, what you're left with is a highly precise recipe, just like this actual kid and lamb starter feed formula. It tells you exactly how many kilograms of each ingredient to mix. So, out of a 100-kilogram batch, we need exactly 37 kilos of maize, 15 of groundnut cake, 25 of palm kernel cake, or PKC, 20 of wheat bran, and half a kilo of salt. There's literally no guesswork involved. Every single gram is accounted for. This ensures the young animals get the exact nutritional profile they need to thrive, and you aren't wasting a single cent on excess, unnecessary ingredients.
Okay, let's bring it all home with Section 5, Steps to Perfect Feed.
Let's take all this theory and put it into practice. The order of operations here is absolutely vital. You've got to execute step 1 first, which is balancing your crude protein and energy levels, typically using at least 3 distinct feedstuffs. Do not pass go until that's done. Only when that baseline is locked in do you move to step 2. That's where you rigidly check your formulation against critical amino acid requirements. You have to verify that indispensable amino acids, things like arginine, lysine, methionine, and tryptophan, are present in the exact right amounts. If your formula is a bit low in any of those, well, you add a specific feedstuff to compensate. But here's the catch. You then have to immediately go back and recheck your protein and energy levels to make sure your new addition didn't just throw the whole entire mix out of whack.
And that actually leads us to a really fascinating realization. There is truly no such thing as one single, permanent, ideal formulation, period. Remember, a formula is only ever as good as the availability and the cost of its ingredients on any given day. You might have the absolute perfect recipe today, but if the price of soybean meal suddenly skyrockets tomorrow morning, that formula is no longer economically viable. You have to swap it out for an alternative, recalculate all those amino acids, and generate a completely new ideal feed based entirely on that specific day's market conditions.
So, I want to leave you with a question to think about. I highly encourage you to take a hard look at your local agricultural resources today and ask yourself, how would today's market prices force you to redraw your own Pearson square? Are you actually using the most cost-effective basal feeds available in your area right this minute, or are you maybe stuck relying on an outdated, expensive formula? Dive into your local data, run the math for yourself, and take back control of that 75% production cost. Thanks so much for joining me for this explainer, and keep learning.